Welcome back. In this video, I'm going to expand our studies on area from two-dimensional figures to three-dimensional figures. So we're going to begin with some vocabulary. Polyhedra are solids which are made of flat faces. And the faces are polygons, and the lines of intersection of the polygons are the edges. So here we have a variety of polyhedra, and you can see they're all made up of flat faces. Some of the faces are triangles, some of the faces are pentagons, some of the faces are rectangles or squares. But regardless, the faces are polygons and the edges are the lines of intersection where they meet. We're going to work most frequently with prisms. And prism is a subcategory or a type of polyhedron. Okay? Prisms have some characteristics. They are made up of two congruent parallel faces or the bases, not necessarily the bottom. So something like this would be a prism. This would be a rectangular prism. It's got two bases, and the faces are all rectangles. Okay? The base here happens to be a square, but sometimes the base is going to be a rectangle. And yes, the faces are also parallel, but we only have the two parallel bases. So these are the bases on the right and the left-hand side. Okay? We could also have a triangular prism. This is a triangular prism. Okay? My bases are triangles. They're parallel to each other. And I have three rectangular faces. The lateral faces are the faces of the prism that are not the bases. Okay? And the lateral faces are always parallelograms. Okay? And oftentimes they're going to be rectangles. So even here I've got an octagonal prism. My base is an octagon, and my lateral faces are these rectangles. And then the lateral edges are the edges that are parallel, and they join my two bases, my two octagons. And we're going to work most often with right prisms. And that means the lateral edges are perpendicular to the base. A right prism will not be a leaning tower prism. Okay? So my prisms are going to be perpendicular to the base. Okay? They're not going to lean at all. Okay? So that's what we're going to work with most often, is a right prism. It doesn't necessarily mean it's a right triangle. Okay? So like this is a triangular prism, but it's a right triangular prism, but it's not a right triangle. Okay? Right meaning it's going to stand upright. And we can calculate the area of a prism by just adding up the area of its individual parts. So more vocabulary, the lateral surface area of the prism is the sum of the areas of the lateral faces. So if I have my triangular prism here, the lateral area is the area of these three rectangular faces. And then, of course, my total surface area would be my lateral area plus the area of my two triangular bases. Okay? So you'll need to know how to calculate the area of triangles, how to calculate the area of rectangles, to calculate the total surface area of this triangular prism. You will need to be familiar with your area formulas, areas for rectangles, squares, triangles, regular polygons. Okay, I've got a regular octagon here. We'll probably use a regular hexagon, which will allow us to use our 30, 60, 90s and 1/2 Potham times perimeter. Okay, so you'll need to be familiar with your Pythagorean triples and your special right triangles. And we'll get some practice problems when I see you in class.